So as I go further into reverse engineering this driver board, or this NIXIE 2 board, I found an appropriate edge connector. Hopefully this will focus here. I've printed out some labels to give me some ideas what the pins are. I've used a marker just to kind of group, hours, minutes, and second pins together. The ground and +5 are labeled here. Again, ground and +5, and the NIXIE voltage. And I've just drawn some lines in on both sides that match up with the alignment slots here on the board. So in this case, the connector would go on this direction. So I've got myself a little cable, or a little connector here, which we'll be able to use. The next thing I've grabbed is just some scrap wire out of my junk box, and I'm going to use to create the power connections for the board. But the first thing I really want to do is just take another look at the board electrically. So let me turn on the meter here. Actually, let me find a meter here that you can actually see on screen. I'm going to go to resistance. Let me get a couple of test leads. And what I'm going to look at, hopefully this is somewhat shown up on camera, is between power and ground. Oh, I've got too many probes floating around here, too many meters. Let's go to the 400K range. The meter zeros. And I just want to take a look at the power rails. So I'm seeing 14.7 K ohms. And 155 K ohms in the other direction, and that's fine. That tells me there really isn't a short on the device. We do see some diode effect through the ICs, which is normal. So, I'm looking for very low resistance, and I'm not seeing very low resistance. The next thing I want to do is get on the NIXIE connection, and I should see opens to both sides. Let me go down to like the 400 ohm range. Again, I should see opens. Bring it up to the 40 meg range. And again, I should see opens. And what that's telling me is the high voltage in the NIXIE, which comes across the board through this dropper resistor, through the dropper resistors in the front of the board and into the tubes. And that gives me a good indication that the tubes haven't been abused. There isn't a short inside of the tube. If there was a short inside of the tube, that would pass the high voltage back to the pins on the driver chips here on one of those pins and would create a current path. It's quite possible that when this tube here, when there was the failure, oh shoot, I gotta quit dropping this thing. When there was the failure over here that caused that original resistor to burn on this one, that potentially the high voltage got passed back at least to this TTL, the original TTL device here, and took it out. But from a quick electrical look here, we have differing resistances depending on the direction I measure. We have, let me get on. Where's the high voltage? We have opens there, so that's a good sign. The next thing I wanted to do is get on diode test and take a look at these little indicators. So it's showing a forward voltage of 3.05 volts and a reverse and 1.46 in the other direction. If that was a neon bulb, I would expect that to appear really open in both directions. There doesn't seem to be enough forward current here if that's an LED to light it, which means I wouldn't expect to see. Again, I'm seeing very equivalent resistances here. I don't know still if those are LEDs or not. They do come back to what I believe to be the system ground. So that's ground there. Let me actually get on continuity here, although I have a hard time. Oh, it is going to act with continuity. Let's see if there's a, what did I feel just flax? See if there's continuity to, okay, I think that, so let me show you what I'm doing here. I'm on the 5-volt rail input right here. There's 5 volts going to that stack, 5 volts going to that stack, and going to here. Those have to be LEDs at this point. I don't know what else they could be. And by pulling this pin low, or one of these 2 pins low, or that pin low, you'd be able to light the LED. I would expect to find a current limiting resistor on them. I've actually seen a marking over here that says high voltage and another potential dropper resistor there, which is interesting. So that's kind of interesting. I don't expect to see continuity between these. Let me go ahead and put the edge connector on. It'll make what I'm going to do a little easier here. And that is backwards. It goes on in this direction so the labels are correct. And I'm going to get on one side of this and just look for continuity. Get on one side of this guy. Again, not really expecting to see continuity, but so let's see, I believe that's the +5 side of the colon. There it is. The problem is I'm having a really hard time seeing where the other trace goes. It's that solder connection there. Is that also +5? Is that the center pin in there should be the +5. So in this case, we've got one of the LEDs comes along this second track, which is the third track in. There's our 3 current limiting resistors for the LEDs. So I really do suspect these are the current limiting resistors for the LEDs. We can actually prove that by going to the other side of the LEDs. Okay, one of them comes to that resistor, one of them to that resistor, the other one to that resistor, and the single one to that resistor. So, this is interesting. Yeah, these resistors are the current limiting, and there's a different value resistor here for the single decimal point over there. So, on the other sides of those appear to go off to 7400. Hmm. Ah. So to that NAND gate output, that NAND gate output, actually we can see the connection here. Or is that a plate through? No, that's actually connected to that pin. Yep. And this one, oh, that loops up through to some place. Oh, that trace runs up off. Anyhow, we've proven these are LEDs. You know, they have a forward voltage that's different from the reverse voltage. Forward was about 1.7, reverse was 3 point something. There's current limiting resistors on them, which of course if they were neon bulbs there would be as well. There's 5 volts to one side of the little stacks, which is going to be the power, and then there's a NAND gate here through a current limiting resistor that pulls the other side low to light them up. So we have proven that my guess those were early LEDs is correct. I mean, I remember buying LEDs in that package style at Radio Shack when I was a teenager. So, you know, that would have been in the 70s. So, a long time ago. So I'm more confident I'm going to be safe to apply power to this. There don't seem to be any shorted ICs on the board. I'm not seeing a short between +5 and ground here. I'm not seeing any leakage between the NIXIE 200 volt input and the power supply rails. And that tells me there's not an internal short in one of these tubes, because if there was, I would see continuity from that 200 volt in through the dropper to resistor. You know, I would see a resistance into the tube, and then the shorted to the tube back to one of the driver ICs and to its VCC or ground. So I think I'm safe to apply power to this to begin to play with it further. I think the next thing I'll do is kind of build up this little wiring harness. Got 3 pieces of wire here with some nice length to them that can reach over to my bench supplies. I will use red for +5, the blue for ground. I would have preferred black, but that's what I had, and the white for the high voltage. Actually, the white might make more sense as ground. It's a little heavier gauge. Although the current flow through the tubes is very minimal, but the white probably makes better sense as ground, even though the color coding is ridiculous. I may put some shrink tubing on the other side just to indicate what they are. These will get attached to the lugs here. I'll put some shrink tubing over them, especially over the high voltage here, so I don't accidentally slip a probe into it or put a finger onto it. Because the 170 volt or 200 volt, I'm used to driving NIXIEs at 170, but this is labeled 200 volts. Because the 200 volts comes in and follows this trace, you can see there's a very narrow gap there between what's a TTL logic level and 200 volts, and that gap is very narrow. It comes up into this cap, a little wider gap, but it would be really easy with a probe to short across those and drop 200 volts onto the input of a TTL device, and of course that would destroy the device and potentially cascade through and destroy other devices. So I'll need to be a little careful with that. My opinion, there should have been more clearance in this layout, although it would have made getting the logos could have been moved around a bit and there could be better clearance. But it is what it is. So anyhow, when I come back, we'll do some soldering, some shrink tubing, and I'll just apply some raw power and see what we get. So I'm going to go ahead and begin wiring this up. So we'll need to make a ground connection. And I'm actually going to wire this up on the back side of the card here. So I can get that through the hole. Hopefully I can get that to take solder. I guess we'll find out. Where's the tip cleaner? So I'm going to use white as the ground since it's the heavier gauge. I said before that I think it's really necessary here. Red will be the +5. And blue, the ground. It didn't strip very clean. If I just said blue, the ground, I meant blue as the high voltage. Again, this doesn't have to be perfect. This is really just a test rig. And the blue will come through the high voltage link over here. The wire's stiff enough that it wants to rotate it. Get this panel out of the way. I was using that as a to block some incoming sunlight in the previous video. That really gets the 3 of those. I need some shrink tubing. So I will definitely want to. I probably should have put the shrink tubing on first as these are twisted together, but I will just untwist them. Red, yellow. Hopefully there's a piece of black in here that'll work. Hopefully that'll fit over that. It should. There we go. Red. Actually, I might have some white shrink tubing to use with the white wire. I do. It's a little long, but it'll be fine. Oh, no. No. Changing my mind. I need to stick with the color coding that I'm used to using, which is yellow is high voltage, red's +5. Black is ground, and what I'm going to do is put shrink tubing on the other ends of the wires to indicate the color coding as well. I don't want to have to think about it. Heat gun. Heat up for a second. I'll need 3 more pieces of shrink tubing. For the other ends of the wires, just go ahead and shrink these. Yes, that is warm. Get the other ends of the wires, and the white wire is ground. The black. Red wires +5. I know that's red shrink tubing on red. And the blue is high voltage. Some black tubing here, and we'll go ahead and turn this into a little harness. If I can find the flush cutters I just used. Now scissors will work. I just noticed in the nicks and these that red wire, it's really been chewed up. I hadn't noticed how bad that was before. In fact, the blue wire might be broken there. Well, crud. That's not encouraging. Last thing I need is there to be an exposed place on the blue wire for the high voltage to get out. Can't ever be easy. Okay, this is a temporary harness. I'm not super worried about long-term reliability. Do I have any other exposed spots in the blue wire? I do have an exposed spot in the red there. We'll cover that up. Maybe. Always got to be an issue. It's just kind of par for the course. I see more where the red wire's chewed up here. Can't get a hold of the piece of shrink tubing. It's determined to stay in the container here. Ow. Now I can't pick the red wire up. It's, oh, come on. As you can see, luck right now is not on my side. Let's get that down there. Just cover that over. Should have inspected this wire first, although I don't have a whole lot of other wire laying around here at this kind of length. Which is kind of why these colors got chosen, was it was the wire I had on hand. Let me hang this up to cool. Boy, I really don't know where the flush cutters went. There they are. Let's strip these down a bit. And we will tin the ends up just to make it easier to connect into the power supply. Shoot. A little too aggressive there. Took a bunch of the wire with it. What do you want back there, Rosie? Oh, she's just being a brat back there. I'm tinning these up just to keep them from unraveling. Make it a little easier to deal with. Now we have power brought out to the board. Next thing I'd like to do is use some of these 0.1 headers, and that way I can use regular breadboard jumper leads to clip on the end down to the breadboard, and then I can just move wires between the plus and minus 12 rails. Really to you know, just move it to a 1 or a 0. So we'll see if I can have any luck soldering these on here. Don't honestly know if this is going to work or not, but I'll find out. Flux might actually be useful here. Let me see if I have any chance of soldering one side of this on without burning myself. I've had trouble soldering to these pin headers before. Yeah, see, either I'm not letting the solder cool down long enough. Nope, really can't get the pin header to take solder. I don't know what the material in it is, but it really doesn't want to take solder. So this idea probably isn't going to work. Makes me wonder if those are aluminum, maybe, rather than steel pins. Wow, that is really crazy. Well, one more attempt. We'll let it cool off here a little longer. Maybe I just wasn't letting it cool off long enough. So these two pins will be used to bring +5 and ground down to just a regular prototyping card. And then I want 3 pins. For those. See, I didn't say this was going to be elegant. Actually, I should have only applied solder to one pin to begin with. Oh, just having no luck with the tools today. Man, can't keep my hand still. I just want enough on there it'll hold in place. Okay, that is really not what I wanted to do. Another group of 3 pins. I want to spread out the wider side here. Maybe trying to pre-tin those would help. You know, 2 of them readily took solder. One of them really doesn't want to. Yes, it's very warm. I don't know how well this is going to work. Oh, Rosie, you're such a brat. Well, it's not perfect. And I'm going to focus on, I think, just the hour pins here for now. One, two, three, four, five. Let's see how much luck I have bending these to a reasonable size. Tin up the center pin as best I can. And we will And I need to get on the 3 control pins on this side because I suspect one of those selects which one of the hour banks is used. We kind of looked at that earlier. So I'll get some solder on the center one here, on the center here. Get those bent back square. Come on. See if I can get that to take solder. Long enough to tack it in place. Not elegant in any sense of the word, but for what I want to do at this stage, it'll be good enough. I'm making a guess that the I/O here selects the hours, minutes on one side or the other side. That the 12 here selects 12 or 24 hour for this side, that the 12 here selects 12 or 24 hour for this side. OF was off. I'm guessing maybe blinks the tubes. I don't know that. And WV here seems to be some kind of a pulse coming in. Perhaps from WWV. That's certainly a shitty looking solder joint there. Excuse my French. They're all pretty crappy looking solder joints. And these pins just don't take solder well. So, next thing I'm going to do here is get all the bits of wire and solder off the table. Where's the brush? I'm going to hook up just power and ground over here to my Rigol power supply. I'm just going to use one of the direct 5-volt taps on it. Oh, why won't you go down through there? Go. I'm going to set a current limit on this. Current limit. I'm going to set it to 300 milliamps. Meter out here. I'm going to connect the ground lead to that ground there so I can just kind of poke at 5 volts, and let me turn number 3 on. That's not what I expected to see. Current limit. Oh, Current limited the wrong side. Let me go to 3. Current limit. And I'm actually going to start at 1/2 amp. Well, it's drawn 490 milliamps. Let's see how close to 5 volts we have here. Well, that's not encouraging. If I got an open lead, oh, that would blow. Oh, I'm on the wind compliance here and I just don't realize it. Directly on the power supply. Well, we've got 5 volts at the power supply. One of these leads must have a break in it. That makes me unhappy. Or I didn't get a good connection here on the ground. Okay, back on. There it is. I had a bad connection over on the power supply side. So currently the voltage is set to 5.2 volts. I'm going to lower it down to get it spot on 5. So the power supply is driving 5.06 volts. We're seeing 5 volts at the board, so there's a little bit of loss, of course, in the wire coming out. And I've got a lot of loss by the time we get to here. 4.3 volts. That's really low. 4.96. Maybe that's not the VCC pin. Matter of fact, it wasn't. 4.93, that should be VCC, 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 I don't remember which pin here is. There it is. And I don't remember which pin on the NIXIE drivers is the 5 volt pin. I know I'm pretty sure it's a non-standard pin out. Doesn't have VCC up in the corner. But there should be 5 volts someplace coming to this device. There it is. So I got 5 volts. 5 volts. Five volts. 5 volts. So I've confirmed all the logic devices have 5 volts coming to them. I'm now going to actually change this up. I'm going to make that the reference, and I'm going to go around the other way and check all the ground pins. Again, I don't remember where ground is. Anyhow, let's check the ground pins. This just tells me I've got ground continuity to everybody. There it is. I could have just buzzed it out as well. but I really want to make sure I have power on every device I expect to see power on. Is that ground there? It is. So what this is telling me is I have 5 volts across every TTL device. Doesn't mean the device is good, but it means at least power is getting to it. And I do not remember where ground is on these non-standard devices. That's got to be right there. That gets me right up near the rail. So at this point, I'm satisfied that I've got 5 volts to each one of the TTL devices. Which is a good thing. The next step will really be to get high voltage on here and just see, check out the colons. So that's cool. Those little red LEDs are lit. So they definitely are LEDs. We're only on a 5 volt supply. They have that early red LED look to them. All 5 of them light up. That's really cool. So in the previous video when I said looking through the little lens, it looked like a square die down in there. It was a little square LED die. So that's really cool. I don't know if we'll get lucky here and actually have sufficient logic signals, incoming to the decoder here, to the drivers, to actually light up a segment, but that's something we will look at next. So let me pause the video here and set up a high voltage supply, and I'll be back. So what I've got set up power supply wise is the top supply is a Heathkit high voltage power supply. It's an IP17. I've adjusted it to be around 200 volts. The ground on it is referenced to the ground down here on the Rigol supply that's producing the 5 volts. So we've got the 200 on the blue lead, or yellow, red lead plus 5 and ground. So that's kind of what the stack of power supplies look like. The bottom supply there is also another Rigol supply that actually goes to higher voltage and has I've just got 2 different Rigols. One can do lower voltage, high current, and one can do higher voltage, a little lower current. But anyhow, that's the power supply setup. Right now this supply is in standby. If I flip this switch up, it'll bring the supply live. So the next thing we're going to do is basically just verify the voltage on the edge connector. So the flying leads I use to get to the edge connector are a little bit short, so it doesn't come into the normal field of view here. I've got marked out with the tape, but it is in the field of view. I've got the common on the voltmeter hooked up. The voltmeter is set to 400 volts. Right now the 5 volt supply is off, but I'll bring up the 200 volts and we'll just get down here on that pin and see if we measure anything. And at the moment, 400 volts. Let me come over to the actual power supply output and take a look there. DC on, there should be 400 volts there. Let me put the power supply back in standby. I'll watch the voltage bleed off. I'm going to take the voltmeter probes directly over to the power supply. So there's our 200 volts. It's set a little bit high. Not that it needs to be precise. So the question is the blue lead got a break in it that's causing this, or did I not get a good physical connection? Again, I think I didn't get a good physical connection into the BNC jack. It's twice that's happened. Let's see if that's any better. Again, this is the reason I'm checking the power supplies. So let's get our ground reference back here. Bring the high voltage back up. And just poke down on there. Oh, you're kidding me. We've got the grounds referenced on the two supplies. So what is it not liking here? Okay. We have to just ohm out that blue wire and see if it's actually got a break in it. So we got 200 volts there. My ground references are common. That blue lead must have a break in it. Oh, that's just tragic. Oh, there it is. That's really kind of weird. So I've moved the ground reference. Does that pin come unsoldered there? That should be a common ground reference. 200 volts back on. Fire up to 5 volts. .200 volts is turned off. It's bleeding down. What the heck's going on here? I should be seeing 5 volts here. Oh, I know why. Ha. I'm relying on the PCB to connect the bottom 2 pins to the upper 2 pins. And without the PCB installed, that is not happening. So the power supplies are off. The high voltage is bled down to 20 volts or so. I'm bringing the power in on the bottom 2 pins, and I'm relying on those solder throughs to connect to the upper 2 pins that I'm hooking the leads onto. Being kind of stupid here, but again, this is why we test. So let me get myself a ground reference again. I'll bring on the 5 volt supply, and I should see 5 volts right here. And let me bring up the 200 volt supply, and we have tubes lit up. That's a really good sign. And we've got 200 volts here. Now I need to be careful handling the board, but I have digits lit on all the tubes. High voltage off. I just don't want to get shocked here. It's not pleasant. That 200 volts could certainly hurt. I'll try to get this in camera shot here. I am holding it by the edge connector, which looks like it should be sufficient, but I'm not going to trust it. I'll get a grip on the board with a little pair of water pumps here. 5 volt supply is on. Let's bring up the high voltage. You can see the tubes have lit. I'm not sure why I have a 7 and 9 both lit in this tube. That may just be that the driver chip needs to be reset, the 7 there is not coming all the way up, and that tends to say, and the 3, that we're not driving necessarily with enough current. I'll push the voltage up a bit and see if those. So at about 210 volts, the 7, there's 225, which is running a little hot. Potentially we'd have to look at the current, but no, that's a really good sign. So we've got digits on the tubes. Like I say, this may just be that the driver chip needs to be reset, and it may also be that driver chip is bad. So really now it's just going to be a matter of me playing with the TTL inputs on it to see what I can get it to do. Boy, you can really see that the top of the 7's hot. So tube may just be showing its age. Bring the voltage back down to 200 and see if it stays struck. It doesn't. But it's a really good sign. So the colon and decimal point are lit up. We actually have values on some tubes. We turn the high voltage off. And it's bled down to under 50 volts. So really, I guess the next step is just for me to get in here and just play with the pins and see if I can determine from the pins what's going on the hours. Those being all 1s, again, is an illegal value. I could, I guess, jumper them all to ground. But I'm going to hold that for another video. You know, we've made pretty good progress here. Supply off. We've seen we have power every place on the board. We've started building a test harness to kind of play with it with. We've seen all the tubes light up, which is a good sign, although we've got 2 digits split in this tube. It could be there's an illegal value actually coming to the tube, you know, a value above 9 that's causing that. There's 4 BCD inputs on that, and that can go from the hex value 0 to F, or decimal 0 to 15, but it can only drive 0 to 9 decimal, or 0 to 9 hex, either way. And so if there's a 10, 11, 12, 13, 14, or 15 on that BCD input, that may be what's causing it to drive 2 segments. Just an artifact of the decoding logic internally. Anyhow, as I alluded to, I'm going to wrap this up here, and I'll get this edited and uploaded hopefully today, and we'll talk soon.